These 5 questions involving discrete and binomial probability distributions. Okay, so there's 5 questions. The multiple choice options have been taken away, but you should be able to do these. The nice thing is you won't have any distractors. So how do we do this? A random variable x represents the number of cars per household in a town of 1,000. So we know that if we were to total this up, we should have 1,000. Find the probability randomly selecting a household that has less than 2 cars. Strictly less than 2. Okay, so they could have 1, 2, 3, 4. They have less than 2 would mean they have 1 or 0. Right? This is over here, so we're just counting these 2. The way we do discrete probability distributions is we take the amount for each one, divide by the total, the amount, divide by the total. Nice that they did 1,000. That moves the decimal over 3 places, so this one's going to be 0.125. This one is going to be 0.428. You could do the same for the rest, but for what we need, we just need to, this is really saying they have 0 or 1 car. So it's an addition that we're going to do. And we don't have to subtract anyone off because there's no overlap. You can't have both 0 and 1 car at the same time. So we're going to add these together. 8 plus 5 gives us 13. 4 plus 1 is 5. And 4 plus 1 is 5. So this is the answer that we're going to finalize. So we'll circle it. That's all we have to have. If you want, you could list this as a percentage. 55.3% of the people in this survey had no car or 1 car. Okay? That's how we can do that. You also, if you wanted to, could just kind of treat this as a regular probability. We could have added 125 plus 428 and then divided by 1,000, and you'll see you'll get the same answer. So both ways work. Determine the probability distribution's missing value, the probability that a tutor will see 0, 1, 2, 3, or 4 students. Those are all listed here. We have all the other ones, but we're missing for one of them. Remember, since it is a probability distribution, these all have to add to 1, 100%. So let's add these, what we've got, and we'll subtract it from 1, right? So we're going to add these together, and then we'll subtract it from 1. So we could start off with just putting here in our calculator 1 minus, put a parentheses because we're going to add all the red, or you could subtract each one, however you do it, but just make sure you get the proper order of operations. So those are going to give us a total. We'll subtract it from the 100%, 64%. So the answer is 0.64. Because of the way they've got it, we really wouldn't want to put 64% because we've got everything else as a decimal. So what goes here? 0.64. That makes the total add to 1. Okay, total has to add to 1. All right. Question, the next one. No, these are jumping around, but I just copied and pasted them from the practice tests. According to police sources, a car with a certain protection system will be recovered 85% of the time. If 300 stolen cars are randomly selected, what is the mean and standard deviation of the number of cars recovered after being stolen? So well, you have to recognize that this is a binomial. You will either recover the car or you won't. So this 85 is a probability of success recovering a car, so P equals 0.85. In a binomial, they have a number of trials. In this case, we're dealing with 300 trials, so that's our n equals 300. And then what you have to know is we're going to need this for the formulas is what is Q? Q is a probability of failure. So that's going to be 1 minus 0.85. So Q is going to be 0.15, right? Do this one up here. And now I'll write it down here to make it a little clearer. So we have two formulas for binomials. The mean of a binomial distribution is going to be equal to n times p. The standard deviation for a binomial distribution is the square root of n times p times q. N times p is going to be 300 times 0.85. Let's calculate that. 255, that's our mean. Standard deviation will be, I guess I'll write it out, the square root of 300 times 0.85 times 0.15. So we do the square root first. We put our 300 times 0.85 times 0.15. Standard deviation is going to be 6.184. Don't tell us about rounding, but we could put these in here. So we could just label this as our mean is 255. And our standard deviation, I'll abbreviate that as SD, is 6.185. Rounded to 3 decimal places is usually pretty good. Okay, and I'll circle it as my answer. And that's good. 2 more questions. Assume that male and female births are equally likely and that the birth of any child does not affect the probability of the gender of any other child. So they're independent. Find the probability that most 3 boys in 10 births. Okay? So this is a probability, a binomial distribution. They're equally likely. That means that the probability of a success, P, would be equal to 0.5. Probability of failure is also 0.5. Okay, so we can use the probability at most 3 boys. At most 3 boys. So that means, yes, we could have 3, but we can't have more than 3, right? At most 3. So that means 0, 1, 2, or 3. But not 4, 5, 6, and all the way to 10, right? So not this group. This is what we're looking for the probability of. Now, with the numworks, we do also have binomial distributions in here. For binomial distributions, what we have to enter is the number, the n. So the n is going to be the number of trials, which is 10. And then we have to enter p, which is probability of success, which is 0.5. So we'll put in our 10. We'll put in our 0.5, which is already there. And then we have, what are we going to calculate? Well, we can calculate all of these things. This one down here is equal to a particular number. So you could figure out 0, 1, 2, and 3 and then add them together. But there's an easier way. We can go to this one, which is less than, and it's actually less than or equal to. So be careful here. Had they said less than 3, right? 3 would not be included. You wouldn't want the equal to. So this is going to include the equal. So if I put 3 here, it's going to include 3, 2, 1, and 0. Okay, so less than 3. It's going to give us a 17% probability. Okay, so we can list that as 0.1719, which we could also list as 17.19%. Okay, and you see that this is binomial. It's a 0, 1, 2, or 3. So watch that carefully. Some of the questions are asked with the less than at most. Could it be equal to that endpoint? If not, we would, if this was less than 3, we would have put actually 2 in here because this is less than or equal. Hope that makes sense. Okay. Again, ask questions if anything doesn't quite make it there. An airline has a policy of booking as many as 150 persons on a plane that seats 140, called double booking, right? Past studies indicate that only 85% of booked passengers show up for their flight. Find the probability that if the airline books 150 persons on a 140-seat plane, not enough seats will be available. This is binomial. People show up or they don't. So this is going to be probability of 0.85, right? They either show up or they don't. Q would be 0.15, but we'll see we don't need that for this. The number of trials, the number of people we're going to book is 150. Those are the two values we need at the beginning. And we want to see if the probability not enough seats, that means that we had more than 140 people show up. So we're getting the probability that X is greater than 140. This is where you'll see we're going to actually put 140 or more. Okay, so what we do here with the binomial distribution, we go back, we put in our number, our N, 150. That's how many we're going to book. How many are going to show up? 85%, 0.85. And then what we want to do is we want to calculate the probability of the flight, basically someone not being able to make it, so that we need the more than. We're going to do more than 140. And notice this includes the equals. If 140 showed up, there would be enough seats for them, right? But if 141, so really what we want is we want X greater than 141 or more. So we put that in here. Oh, not 140, 141. And we get this number, which is a very small number. We have to see what is this e to the minus 4. That is scientific notation. So this number is 5.391. We'll round it that way, times 10 to the minus 4. That means that we will take the decimal point. Scientific notation, since it's negative, it moves back 4 places. 1, 2, 3, 4. 0, 0, 0. They don't tell us how many decimal places, but we've been using 4, so we would say the probability, let's go ahead and use some notation, that X is greater than or equal to 141 would be 0 or 0.0005. So that's actually a very, very small percentage. That would be 5 times out of 10,000, because that's a 10,000th place. It doesn't happen very often. A very unlikely event. So that's why they booked the 150, so that they could almost always be flying with a full plane, making as much money as they can. But on very rare occasions will they not have enough seats for everybody if all this stuff holds. All right, thank you.